stories about water and urban places. This is Ideanthro. Hey everyone, and welcome back to Ideanthro. It has been a little while since I have produced a video because I have got a number of different projects on the go, a few different things in the works, and for the first time in about 2.5 years, I decided I had to park this video making adventure. Except for today. So one of the projects I've got on the go at the moment is I am out assessing a whole bunch of different stormwater treatment assets, nearly 400 of them for a particular local government. And this morning I've come to this system that we're going to talk about today. And it's a very, 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 very large bioretention system. And a couple of things caught my attention about it. The first of which is the fact that it runs against the conventional wisdom that a really large bioretention system can't function. Isn't a good idea. Because, you know what? It's not too bad. And the other thing that struck me, and it's probably what I'm going to dwell on more in this video, is in this large system, it's a very good example of something that I'm beginning to see occur in bioretention systems more and more and more. And that's them developing little niches in different parts of the systems. And it strikes me that so far, for the most part, our management of bioretention systems has been quite homogeneous. So if we're talking about the planted element of the bioretention system, it's essentially been manage the planted element. But the more and more I get around looking at these particular assets, these particular sites, the more I'm noticing that within given systems, and it's most apparent in really big systems, so we've known about certain elements of this for a while, but this does apply even to really small systems. But within these systems, we have particular niches, particular areas that aren't just the planted area, but are the planted area that's slanting in this direction, or the planted area that's slanting in that direction. And so I want to talk about these two particular things. Really briefly first, I would like to show you a couple of drone shots of this system so you get an idea of its scale. I'm not going to narrate these, I'm just going to stick them up on the screen. They're going to last 30 seconds, a minute, something like that. Just take a look at them so you get an idea of this system. Here we go. Okay, so now you understand just how enormous this particular system is. But also, I feel you should have a pretty good idea of the way the vegetation changes across the profile of this system. And I'm not suggesting it's perfect, because you can see massive gaps in the vegetation of this system, no doubt. So let's address the first topic here. Large systems can't work or shouldn't work or aren't good ideas. There's really typically two reasons that are put forward as to why large bioretention systems are a bad idea. And one of those is really large inflows. Well, we can probably make this into three if we go with this. Let's run with it. Let's split it out into three. Really large inflows coming into the system as a risk of scour. Small constant trickle flows coming into the system, wetting the front end of the system and causing problems because of that. And because the majority of our rain events are quite small events, a wetting or drying gradient throughout the system such that areas closer to the inlet are wetter and sometimes too wet for bioretention systems. And at the other end, you can have the system that rarely ever gets wet and is too dry. Well, this particular system here strikes me that while there's evidence of all three of those things going on, none of them are critical failures. Yes, the inlets are absolutely enormous, but as of yet anyway, there's not massive scour across the surface of the system, nor is there huge amounts of sediment deposition. Yes, one of the inlets in this system does have a trickle flow, and yes, that has created a permanently wet area near the inlet of the system where there is some aquatic macrophytes growing. There's some Leperonia, there's some Chenoplectus as well, but it doesn't extend very far out into the system. Doesn't seem a particularly big problem. On the other hand, yes, there is a drying gradient and the back end of the system is drier, but there are some plants responding to that as well. And so in the first instance, this is interesting because it says, look, okay, there are some risks here, but it is at least possible for a large system to be really quite functional. Now, in the case of large flows causing erosion, it is worth bearing in mind here that it's possible. This system, I don't know how old it is, but let's say it's 10 years old, just as a guess. It could be a little older, it could be a fair bit younger. But let's say that's 10 years old. There's nothing to say that in those 10 years, it's ever actually experienced a really fundamentally large rainfall event. Yeah, because of the way rainfall events happen, you know, lots of heavy storms soon and then none for a while. It could be that this system's experienced a 100-year ARI rainfall event, or it could be that it's never experienced anything more than a 2-year ARI rainfall event. And so we can't be sure that just because we don't see any scour in this system that it's not prone to scour and it's not at risk. You'd certainly, given the enormous size of the inlets, and they're bigger, the pipes are bigger than I am tall. Because of the enormous size of the inlets, we would need to keep an eye on this system over an extended period of time, many, many, many years, and compare that to the rainfall record, be confident if this system was actually resilient to scour. But so far, seems to be doing pretty well. Some small localized depressions, not a big problem. And then that brings us to these ecological niches. So if you came in here and looked at this bioretention system with a straight, just look, does it meet the maintenance guidelines of having this many plants per square meter and not having a wet zone at the front, you'd look at this and it would fail on multiple counts. It would fail on the fact that it's got a constant inflow coming into it and that it's got some aquatic plants at the inlet. It would fail on the count that it's got a drying gradient through it. But I look at this and I'm like, no. This is like nature. Nature develops these little ecological niches within systems, and it just functions perfectly. In this particular case, the fact that this is wet and has some emergent macrophytes and some lilies growing in the forebay at the front is in no way a problem for this system. It extends maybe 10 meters in that direction. I'm sitting right near the inlet. It extends maybe 10 meters in that direction. And then it looks like pretty much like a typical bioretention system from then. Yeah, sure, I can walk down the back end and it's a bit on the drier end of things, but there's Imparatus cylindrica that's growing in there. Lamandras will deal with that sort of condition. So you can have that sort of niche. We've also then got the areas in here that have got plenty of trees in them. We've got some reasonably mature trees growing in this now. Admittedly, they're mainly pioneers. And then we've got areas that have no trees and are understory only. And this is not the only system where I've seen this play out. I saw another bioretention system yesterday. Again, quite large, nowhere near as big as this. But what it had was an inlet that did have some scour, and it had developed a slight preferential flow path around the left-hand side. And because it was a big system, it did have some trickle flow. So it was wet around there and it had some emergent macrophytes in there, but then the rest of the system was just like a bioretention system. And again, that would fail on typical assessment of whether it's a bioretention system, because that bit of it's too wet and it's got those aquatic plants in it and it's got a preferential flow path, so the base of it's not flat. But really, what's the problem? You've got a system. One of the massive challenges with bioretention systems is getting plants to grow in them. But if we've got little niches developing that plants actually really, really like and really want to get into and grow in, isn't that a good thing? Sure, it might not fit our cookie cutter stamp, boom, mold of, I mixed my analogies there, from a cookie cutter, pressed it out onto the tray to a stamp. But sure, it doesn't fit our cookie cutter understanding of what bioretention should be and should look like. But that doesn't mean it's a problem. that actually potentially means it's more resilient, more diverse, more functional. Certainly from a habitat point of view, it's more functional. The amount of dragonflies and little creatures that I have seen while sitting here next to this slightly wet inlet is really quite impressive for a bioretention system. So I don't know whether this means that I'm suggesting that we should be trying to deliberately develop these niches into systems, but it does strike me that from a management point of view, we need to take a step back from our fairly hard and fast. Look, the plant should be of this type and should be homogeneous across the whole surface of the system, and there shouldn't be any sediment built up near the inlet because there shouldn't be any standing water there, or we don't want a drying gradient across the system. You know what? Let's have a drying gradient. Just change the plants to suit it. So I do think from a maintenance point of view, this is very important and should influence the way we maintain systems. Out with the cookie cutter, in with the more holistic look at the system and allow it to develop niches. So I hope you found this interesting. It's a very, very, very large system. I would encourage you to come and have a look at it. I chucked the asset number up on the screen at the beginning of the episode. I would encourage you to have a look at the system, come out, have a wander around, see what you think about it. It's not perfect. You would have seen from the drone shots that it needs way more vegetation. It's actually a funny point here about just how, if you want to get a canopy up in a bioretention system, just how many trees you need in it to do that. But that is a story for another episode. So for now, have a think about this. Let me know what you think. I would love to hear from you in the comments below. Okay, have a good one. I'll see you later. Before you go, our best episodes come from your questions. This knowledge base, these discussions that are Ideanthro, improve with your contribution. So if there's a topic, an idea, a concept that you would like us to explore, come and ask us. You know where to find us. www.ideanthro.com/contact. You can find us on Facebook, YouTube, LinkedIn, and that place you get your good podcasts from. You know where to find us. We look forward to hearing from you. We'll see you soon.